Math 8, this is Mr. Bainey, and we're going to take a look at, hey, what's up, Math 1? We're going to take, hello, this is Mr. Bainey. Let's take a look at lesson 13.1 and 13.2, volumes of cylinders and volume of cones. Last year in 7th grade, you learned about how to find volume of prisms and volume of pyramids. So the concept of volume is something that you've done before, but we're going to extend that a little bit to 3D shapes that have circles in it. So volume, let's do some review here, is how many cubes and cubes are 3D shapes. How many cubes are inside a 3D figure? Now, when we're doing this on a piece of paper, it's sometimes a little challenging to see 3D shapes, but if you can imagine, we have this cube, and a cube means every single edge of this thing is exactly the same. A cube, something like a cubic inch, is a cube where every single side, every single edge is 1 inch long. A cubic centimeter is where every single edge is going to be 1 centimeter, right? A cubic meter, which is actually really big, if you think of meter stick, is where every single edge, every single side is 1 meter long. So how many of these little cubes can we actually fit inside of a 3D shape? A cylinder is you can look at just this picture right here below, and it has 2 bases. In fact, let me be even more specific here. It has 2 circle bases. We'll leave it at that. That's sort of the most important thing. Also, it has a height. I'm not going to mention that, but the height goes directly up and down so that it makes a right angle with our bottom and our top base, our 2 circle bases. But I mainly want to just mention that there's 2 circle bases because for a cone, there is only 1 circle base. And this is going to just allow us to know the difference between a cone and a cylinder. And we need to know the difference because we need to know which formula we're going to use. And don't worry too much about trying to memorize this formula as you're practicing this, but hopefully if you practice it enough, you'll be able to memorize it. Within our formulas for volume of these 2 shapes, we need to know what the area of a circle is because we're going to be using it. The area of a circle, I'm going to write A and a little circle symbol right below it, is pi times radius squared. So remember that squared means times itself. So we're doing the radius times the radius. Remember that pi, if you want to write it right above, we're going to use 3.14 most often. If you use the pi button on your calculator, it's going to use the exact number, but I would be fine with you using either one. The 3.14 is just fine. Remember that R means radius, and that D means diameter. If you ever see D equals, right, D means diameter, and diameter is this line going straight across the circle. It's going all the way. The radius is only half of it, so it's that distance or this distance right here. So if you just take half of the diameter, let's say the diameter was 10, take half of it to get the radius of 5. The volume of a cylinder is going to use the area of a circle. So what I want you to imagine is we have this circle down here at the bottom, outlining it in blue. We're going to find the area of that circle. So the volume equals the area of the circle, pi times r squared. And then we're going to multiply it times the height, how tall the thing is. So h. I'm going to add this up at the top. H is height. Okay, and that's all there is to it. You'll see in the examples below how I actually plug in these numbers, how we write our solution and all that. But let's do the last one before we do some examples. Volume of a cone is, again, we start with the volume of a circle, and I'm going to leave some space right before it. You can do this really anywhere. And what I'm talking about is, in fact, I'm going to write the height because we're going to do the area of this circle, and there's only one base here, remember, in a cone. And we're going to multiply that times the height, that thing. But we don't have the circle base on top, right? The volume of this, if the radius and height are the same as a cylinder, the volume isn't the same. We can't fit as many cubes in a cone as a cylinder. So what we need to do is we actually need to take 1/3. So it's going to be 1/3 times pi times r squared times h. So the only extra thing there is that 1/3. Now, if you would prefer to write it this way, it might be a little easier. You could write volume equals pi times r squared times h, and then divide it by 3. Because remember, that 1/3, the 3's on the bottom. So it's almost like we're dividing by 3. So you could write it this way. You'll get the same exact answer. Let's try an example. Number 1, let's find the volume of this cylinder. Okay, remember we can tell it's a cylinder because we got a circle on the bottom, a circle on the top. We have our radius here. The radius goes from the center to the edge of the circle, and we have our height. So let's label that 3 is our radius, and then 10 is our height. So our volume of a cylinder is pi times radius squared times h. So pi, remember, is 3.14. And the radius is 3. So I'm going to multiply times 3 squared. And then the height is 10. So times 10. So this becomes 3.14. We have to follow our order of operations here. So we do the 3 squared, which is 9. Right? We do exponents before we multiply. And so I'm multiplying 3 things together here. I'm just going to do them all at once. If you just do 3.14 times 9 times 10. Just multiply those 3 in a calculator and we'll get our answer. The solution I got is 282.6. The units are inches for our height and our radius, so it's going to be inches cubed. Remember that this means that I can fit 282 cubes inside of this shape. Those are cubic inches, right? So each side of the cube is only 1 inch, but I can fit 282 of those. That's actually quite a bit. So that's our solution. Remember that you're writing down the answer, numerical answer, and the units for all of your answers. Don't forget that. Go ahead and try the your turn for number 1 off to the right before you see my answer. Go ahead and pause it while you try it out. Here's a solution for the first you try. As you can see, I plugged in my radius of 4. I forgot to label it on my picture. That's the radius. 12 is the height. And if you weren't able to see it, if you turn this thing to or if you rotate the paper over, you'll see that you have this circle is either the top or the bottom, and then this is the top or the bottom. So we have our 2. So that way it looks just like this one over here, the example number 1. So my solution I got was 602.88 feet cubed. Remember, cubic feet, that's how many cubes I can fit inside of that cylinder. Let's go to example number 2. You have a cone this time. Remember that cone is going to require us to divide by 3. So I see here that 9 is my height, 8 is my diameter. If 8 is my diameter, that means I take 8, actually I'm going to write it down here on the bottom corner. The radius is 8 divided by 2, right, which is 4. That is the number I want to use. So whatever the diameter is, always divided by 2. Sometimes they give you the radius, right? Like example number 1. But that's not the case this time. So our volume, I'm going to divide by 3 in this one instead of doing the 1/3. So I'm going to do pi times radius squared times height, and then I'm going to divide it by 3. So this is what it looks like. I have 3.14 times the radius, 4, squared, times the height, which is 9. And then when I do all that, I'm going to divide it by 3. So I'm going to go ahead and just put this into my calculator. 3.14 times 4 squared is 16. So make sure you multiply by 16 and then times 9. I get 452.16. I suggest you make sure you're putting that into your calculator along with me so that you are getting the same number. And I'm going to take that and I'm going to divide it by 3. And I get 150.72. My units are feet cubed, cubic feet. And there is my volume. Try the one to the right. You try number 2. Go and pause it while you practice this one before you see my solution. Just like example number 2, I had to find the radius because they gave us diameter this time. Remember, diameter goes all the way through from one side of the circle to the other, going through the middle. So I divided by 2. Radius is a decimal this time. Shouldn't be that much of an issue. Just make sure your work is nice and organized so you don't accidentally type in the wrong number in your calculator. So 3.14 times 7.5 squared times 16. If you plug in your numbers correctly, I squared 7.5 and got 56.25. So multiplying all those out on top gives me 2,826, and finally dividing it by 3. So our solution, 942 centimeters cubed. Our last example is a word problem. You will have some on your assignment. Snack bar sells popcorn in cone-shaped containers. One container has a diameter of 8 inches and a height of 10 inches. How many cubic inches of popcorn does the container hold? So I'm going to attempt to draw what this might look like. So here's an opening of our popcorn container, and it's cone-shaped. So like this. And the diameter going all the way across like that. That is 10 inches. And going all the way down, that height is, actually I wrote down the wrong number. So 8 inches is the diameter. And the height going all the way down is 10 inches. So if the diameter, that's D, is 8 and the height is 10, we need to know what our radius is. So our radius is our diameter divided by 2, 8 divided by 2, which is 4. Okay, 4 inches. Then to do our formula, volume of a cone means we're going to do pi times radius squared times h, the height, divided by 3. Okay, I'm going to kind of skip a couple steps here, but I am going to show you how I plug in everything. 3.14 times 4 squared times h, which is 10. And I'm just going to plug this directly into my calculator, and I get 502.4. Remember, we're going to divide that by 3. So I'm doing 502.4 divided by 3, and I will get 167. Looks like I get a repeating decimal here. 0.47 is fine. Just round it to the nearest hundredth, and this is in inches cubed. We got one more to go, one more you try. Go and try that out before you see my solution. Please pause it. And here's a solution to the last one. The volume of this time a cylinder. Doesn't tell you it's a cylinder in here, but you do have to assume that a bass drum or any drum is kind of like a cylinder shape. So I drew it as well. That might help you figure out what type of shape it is. And then, of course, what formula we have to use. So this time I don't have to divide by 3. Remember, the formula for a cylinder is just pi r squared h. They give us a diameter, so you can see down here I divided it by 2 to get my radius, and then I plugged in the numbers. 3.14 times the radius squared times the height, and then showed all my work there. Got 6,838.92 inches cubed. Okay, thanks so much for watching the video. Hope it was helpful. Have a good day.